In the next few videos, I want to do some examples from our textbook, Mario Triola's Elementary Statistics in its 14th edition, about correlation and regression. Our problems are going to come from page 541, section 10.2, which is just on regression. But we're going to do the problems as if they came from both 10.1 and 10.2 and determine if there's a significant linear relationship first, and then make predictions as requested. The problem we're going to start with comes off of page 541. We're asked to find a regression equation, but we're first going to use the R value to see if there's a significant linear relationship to start with. And we're going to let x be the predictor value. The first variable be x, which is the predictor variable. Then we're going to find the indicated predicted value using a procedure that we've talked about in class that's also located on page 533 of the textbook. So we're going to start with number 15 here. Use the time tip data from the table below, which includes data from New York City taxi rides. Find the best predicted tip for a ride that takes 20 minutes. All right, so we're supposed to be using the time tip data. And so the way the data is laid out, this is going to be my x and this is going to be my y. And at the end, we are asked to make a prediction for a tip for a ride that will take 20 minutes. Okay, so we'll go on and get started, and I do want to proceed using my TI-84. You can use a TI-83 or an 84 using the procedure that I'm getting ready to use. So I'll start off by entering the data into list 1 and list 2. So I'll enter time into list 1 and the tip into list 2. I'll get started by hitting the stat button and then pressing enter with edit highlight. And now I'm going to enter the data. If I was to make a mistake along the way, like maybe I thought that 31.00 is a mistake, I'd come back up and I'd hit the delete button just to get it out of there and put the right data value back in. It's always worth taking a moment just to proofread the data, making sure we didn't make any mistakes at the data entry level. And now I'm supposed to put the tips into list 2. Always remembering that these are data points, that these are paired data. They need to go together. All right, so I have my data entered into the list. Now I can use my graphing calculator to find both the values of r and r squared along with the prediction equation, the regression equation. So I'm going to hit second quit to get out of this, even though I could have just hit the stat button to go right into the next part. I am going to go over to Calc, and I'm going to choose linreg a plus bx to match what's in your textbook. I'm sure you all saw this option up here, linreg ax plus b. It doesn't matter which one you choose, it just changes the format of the line. All right, well, I could just press enter right now to find what I need, but I'm going to say that my x's were in L1 and my y's are in L2. When you're using L1 and L2, this is unnecessary. If you were using different lists, then that step would be entirely necessary. So I'm going to go and press enter. And what I see here is I get the value of a and b that I'm going to be looking for in a moment, but I don't see r and r squared. And that's because I haven't used this calculator to do this before. So what we need to do is follow a set of calculating instructions that we only have to follow once. And you might have done this in class, but just in case you didn't, let's do it together now. We're going to hit second and then 0. This gets me in the catalog. And what I'm going to do is I'm going to look for the words diagnostics on. And to cheat a little bit, I'm just going to hit the button with a D on it, so I skip down to that part of the alphabet. And so I see D right here on the X inverse button. So I come down here to diagnostic on, I press enter again. I won't have to follow those instructions a second time unless I erase the calculator's memory. All right, so I'm gonna clear that off. I'm gonna go back to Stat, Calc, and then down to linreg a plus bx. Enter. And again, I don't need to put L1 comma L2 unless I have used different lists. Pressing enter, now I see everything that I wanted. And the first thing I'm going to write down is my value of R, rounded to 3 decimal places. And right away I notice that this value of R, 0.298, is a little bit low. Well, I can compare that to table A-6 in the textbook. Table A-6 requires me to know the number of data points in my sample. And I can just look down here in the list to remind myself that there were 8 data points in this sample. I could also just go back to the data itself and count the number of columns. And now I can find a critical value for R. And I see that my R value of 0.298 is much lower than 0.707 and even lower than 0.834. With an alpha of 0.05, I'd have to have an R value, an absolute value that was greater than 0.707 to be significant. This is lower than the stated critical value. So we can conclude that there is not a significant linear relationship. Between the time and the tip. If I was to write down the regression equation, which I'm asked to do in the text, I could write it down like this, y hat being our symbol for these y values that come from a sample. All right, so y hat equals, and then a, and so I'm going to round this to 3 decimal places, plus bx, where b is 0.042x. That's my regression equation. But what we just said is that we shouldn't use it to make a prediction. There's not a significant linear relationship. This equation doesn't really do a good job of modeling the relationship between the x's and y's, so I shouldn't use it. But in the problem, I'm asked to make a prediction, right? I'm asked to find the best predicted tip for a ride that takes 20 minutes. How does this result compare to the actual tip amount of 455? And so what they're telling me is that if I look through here, if I had more data points, there actually is one at 20 minutes, just not included in this little list in the sample that we're using. So we're given a little bit more information there. Well, if I want to represent all of the tips with one value without knowing anything else, which is basically what this says, there's not a significant linear relationship, then we're told to use an average. So to make the best prediction I can for the tip at 20 minutes, I'm going to find an average of all of these tips. And since there's not very many data points, I'll just do this the old-fashioned way. And I don't really have to add the 0 in, but I'll need to remember to divide it, to count it when I'm counting the data points to know what to divide by here in a minute. All right, and so there's 1, 2, 3, 4, 5, 6, 7, 8. Divide that by 8, and we'll have our average, about 1.68. The average tip is $1.68, which is the best prediction I can make. Because when there's not a significant linear relationship, that's the best we can do. Is tell someone that, well, the average is $1.68, so for a 20-minute cab ride, I'm going to guess it's about $1.68. We're asked to make a comparison here to the $4.55 that apparently was the actual tip, and it's pretty far off. And the lesson here is really just, sometimes it's hard to make predictions when we don't know any more information. The best we can do is an average. Well, that's it for problem number 15. In a moment, or in the next video, you'll see a solution to number 17.